Hey, this video is on how to calculate superheat and subcool. I'm going to use two things as information here. I'm using the start here. If you look at it, it's just a basic system. You got the evaporator. Over here is suction line going to the compressor. Your discharge or hot gas line going to your condenser. Your liquid line going to your metering device. And then back to your evaporator. Also, I got this printout. I don't have my gauges with me, so I'm just going to go ahead and use this. And I marked these pressures to correspond with what we found today or yesterday in the class. And so I'm going to refer to those numbers. And it's very simple how to calculate superheat and subcool. Basically, to break it down as easy as possible, superheat happens, again, if you know your definition, it's added heat past the point of saturation. So here in the evaporator, when you get to 90%, it's when saturation happens. That's vapor saturation, where the liquid coming in is completely turned into a gas. And it happens at 90% of evaporators. So once you hit 90%, think of that as kind of a stop sign. And that's where the door opens into superheat. It starts in the evaporator at 90%, and you begin to enter into superheat. And what that is the heat being added after you've already gone into the vapor. Now, again, this is sensible heat. This is when your temperature starts to rise on the thermometer. With that, you're going to be able to measure the amount of superheat. So we'll get to that in a minute. But going through the suction line into your compressor, through your hot gas line, entering into your condenser, that's where we no longer measure superheat. Now you're going into your condenser. It's going in a high pressure, high temp liquid vapor. I'm sorry, going in a vapor. When it gets to 3/4 of the way, or 75% into the condenser, that's when you enter saturation of liquid, or liquid saturation. And what that means is, again, you're entering into a door where it no longer is a vapor mix, uh, turning into a liquid. You hit the point where it's complete liquid going out. Now, same thing. That's a door where you're entering into subcooling. And that, again, is going out of latent heat, and now you're entering into sensible heat, where you can now, again, measure in the thermometer, and that's where we're going to measure subcooling. So what I did was, we're going to use the numbers that I got from class. We connect our gauges, high side and low side. Again, the high side will be connected right past the condenser. The connection point is somewhere here in the liquid line. And the low side will be connected into your suction line past the evaporator right before you get into your compressor. Looking at the gauges, we see that this is our high side. Now I had a pressure of 230. Here it's marked PSIG. And on the low side, it was at about 70 PSIG. Now there's two ways that you can find out the saturation temperature. The first of which will be, I was using R22, so we go to R22, and here I circled the number. You find the saturation temperature on each one. On the high side, you're looking at about 111 degrees Fahrenheit for a saturation temperature on the high side. On the low side, you're looking at about 40 or 41 degrees Fahrenheit saturation temperature on the low side. Or you can just simply look up at the chart that you have in the lab, and you can match it up with your pressure to your temperature on R22. Either way, so we got at 70 PSIG of pressure on your low side corresponds or relates to 41 degrees Fahrenheit on your low side. That's your suction saturation temperature. That's the temperature of it coming out. Once you hit 90%, that's the temperature of it coming out of the evaporator. And then going into the condenser, you're looking at after saturation. You're looking at, it was 230 PSIG, which corresponds to 100, about 111, give or take, saturation temperature inside the line. That's the temperature of the coolant inside. So what I did is I already have here the formula for superheat and subcool. Here on your low side, I got my saturation temperature, and I put it here. That's 41 degrees. Remember, it corresponds with the pressure. This is temperature, not pressure. And then I got my suction line temperature. Now what that means is I got my thermometer and I went to the big line, the big copper piping, the one that's insulated, and I put my thermometer in there and I took a line temperature. And the line temperature came to 60 degrees Fahrenheit. And so the formula is you take your suction line temperature, which was 60 degrees Fahrenheit, and I subtract the saturation temperature of 41 degrees, which is what our gauges told us, and that gives us 19 degrees of superheat. And remember, superheat is the heat added after it's leaving from the 90% mark of the evaporator into the line before you get to the condenser. Now the subcooling, after you hit the saturation point at 3/4 of the condenser, it's going into the liquid line. What I did was I got my saturation temperature of 111, remember it corresponds to 230 psig, and then I took a line temperature of the high side line. Now that's a thin copper piping coming out of the condenser. You would take the line temperature there, just get a piece of tape or something, wrap it around it, you should have it on it, and take the temperature. And then what we do from there is we subtract that temperature, I got 87 degrees, and subtract it from the gauge temperature, or the saturation temperature of 111, and it gave us 24 degrees of subcooling. Again, that is the heat lost, because you're cooling, the heat lost after you left the condenser at 3/4 of the way through the condenser. You start entering into, again, sensible heat. And we'll talk more about sensible heat and latent heat in a minute in another video. But here, just know that now your thermometer is again registering heat or loss of heat when you're entering into subcooling. Okay? Low side, superheat. High side, subcooling. I hope this helps. Feel free to ask any questions or send any emails.